Hi everyone, my name is Sylvanus Deborah. I'm a student of Fountain School. I'm in SS1. Today I'm going to be talking on the topic modular arithmetic. Modular arithmetic was formed by a man known as a German mathematician whose name was Carl Friedrich Gauss in the year 1801. He made a book known as Distinguished Arithmetica to help and allows us to create easily fundamental building blocks in the key to crypto system. It is commonly used to limit the size of integers. So today I'm going to be treating on the topic about addition and subtraction in modular arithmetic. I'm going to give an example using a clock to explain addition in modular arithmetic. Zero represents our 12 because this is in mode 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now, if a question was asked, 7 plus 8 is equals to 15. And in this our clock, 15 is not written as a whole number. So we're asked to find which number in this clock is equivalent to 15. And we know there are 24 hours in a day. And if we divide by 2, we'll get 12. So now to get the number equivalent to 15 in this clock, we go in a clockwise direction. Starting from 0, we represent our 0 as 12 and begin to count. 12, 13, 14, 15. So we found out that 15 is equivalent to 3. But how? Now I want to know what is the formula behind this. We can, because people want to understand 15 is equal to 3. How? So if we solve this manually now, this operation I'm going to solve here will now define the true meaning of modular arithmetic. So we say 15 divided by 12 is equals to 1 remainder 3. And mind you, modular arithmetic is defined as the art of computing remainders. So here, our 3 comes to place. This is how 15 is equivalent to 3 in our operation of this addition. This operation that I carried out here is the actual meaning that defines the meaning of modular arithmetic. That is why modular arithmetic sometimes can be known as clock arithmetic. So now I'm going to give another example using charts. Here is going to be our days / weeks. Here we have Monday. Sorry, Sunday is going to be here. Sunday is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. We are going to use letters to represent this. This is our chart. This is in mode 4 because the numbers that occurs in mode 4 is 1, 0 to 3. So we are going to use letters, then we now use numbers. So we say A, B, C, D. A, B, C, D. A, B, C, D. A, B, C, D. A, B, C, D, then A. Now, we're going to solve some additional questions using these letters of charts in modular arithmetic. First, if we ask a question, A plus 5. This means what day of the week with 5 days from A land on. So we'll count 5 days from this A, starting with that is 1, 2, 3, 4, 5. Our answer is equals to B. I'm going to use circle to make this more understandable to you. So I'm going to solve one more. If we were asked D plus 8. That means 8 days from D with land at, what is it going, which letter is it going to land at, and at which day of the week it will land at. So we start counting from this day. That is 1, 2, 3, 4, 5, 6, 7, 8. Our answer is equal to D. This might look somehow confusing, but now I'm going to make it more understandable for you using a circle. So now, this our circle will be in mode 4. 0, 1, 2, 3. And this our chart is in mode 4. That means this is 0, this is 1, 2, and 3. Now, they said 5 days from A. Our A represents 0. So we start counting. 1, 2, 3, 4, 5. Which is equals to this A plus 5 is equals to 1. And in our chart, B is represented as number 1. That is how this came to pass. Now, this 5 days, 8 days from D is equals to D. And in our chart here, D is 3. So this is D. So we'll count 8 days from this 3 over here. 1, 2, 3, 4, 5, 6, 7, 8. It still landed at D. That means this D plus 8 is equals to 3. It is still the same thing as this. It's just that to make it more clear and understandable to you, we can use circle or chart to represent this equation. So now we're going to move to simple additional questions, because addition is one of the simplest parts in modular arithmetic. So that is all for charts and circles and clocks in modular arithmetic. So now we have this simple question. 6 plus 14 in mode 7. In normal addition, 6 plus 14 is equals to 20. This is our answer, but there is a reason why we can't leave this as our answer, because it is in mode 7 and 20 is bigger than 7. The only number that can occur in mode 7 is 0, 1, 2, 3, 4, 5, then 6. And as you can see, 20 is not above because it's bigger than 7. So what we are going to do is this 20, we divide it by our mode here, which is 7. 20 divided by 7, as we know, is equals to 2 remainder 6. This is also not our answer. So now in modular arithmetic, it deals with the remainder. So therefore, our answer is equals to 6 mode 7. We can pick this here because this is part of the number that occurs in 7. It's not bigger than 7. So that is why our answer is 6 mode 7. So I'll solve another question. 20, number 2 first. 20 plus 8 in mode 5. As I said, addition is very simple in modular arithmetic. So 20 plus 8, as we all know, is 28. We all know why we can't leave an answer in 28 as 28, because it is bigger than 5. So we divide it by 5, which is equals to 5 remainder 3. So therefore our answer is 3 mode 5. As you see, due to what we have solved there, as you can see, modular arithmetic is very easy, especially in the addition in modular arithmetic. So I'm going to move on to subtraction in modular arithmetic. This is another simple part of modular arithmetic. So now I'm going to solve another simple question in subtraction. Number 1, we have minus 30 in mode 4. this question might look very well. Minus 30 in mode 4. There is nothing you use and minus with this 30. You just minus 30 in mode 4. Like I said, subtraction is very easy in modular arithmetic. All we just have to do is do minus 30 divided by 4, which is equals to 7 remainder minus 2. Why our minus did not come over here? Because modular arithmetic is all about the remainder. So we move our minus will appear at the remainder. And as we know, our modular arithmetic, our answers do not appear with a negative sign. So we therefore say minus 2 plus 4, which is equals to 2. So our answer is 2 mod 4. As I said, it's very easy. So we're going to solve some questions involving subtraction in modular arithmetic. First of all, I would like to start with this simple question. 6 minus 4 in mod 3. 6 minus 4, as we know, is 2. Therefore, our answer is 2 because 2 is one of the numbers that occurs in this 3. So answer is 2 mod 3. Easy peasy. But now, I'm going to give you another question that will involve us getting our answer in minus. Now, 5 minus 7 in mod 3. 5 minus 7, our answer is minus 2. We can't leave an answer with a negative sign in modular arithmetic. I'm going to use a circle to represent this equation here. 0, 1, 2. This is in mode 3 because the only numbers that occurs in mode 3 is 0, 1, and 2. So now, say minus 2 in mode 3. So we're moving in an anti-clockwise direction. Move with anti-clockwise direction because it comes with a minus sign. So we're going to move 1, 2. We're going to move 2 times because it's the minus 2. 1 and 2. Our answer is equals to 1. So now, we can't keep on doing this every time because you don't know, you might have a question that includes a very large number. So you cannot just come and start drawing big, large circles. So how we are going to get this one here to turn into a positive number? We are going to add this our 3 to our minus 2. That is minus 2 plus 3, which is equals to 1. This is how our 1 came about. So this method is much more easier than using this method. Or if you like, you can use it. But just for clarity's sake, use this method. Thank you. So now I'm going to move to division. This is a very tactical part of modular arithmetic. And I'm going to show you how easy it is. First, I'm going to start with the easy questions involving this division. Number 1, 10 divided by 2 in mode 5. This is very easy. Just 10 divided by 2 is equals to 5. We can't leave our answer in 5 because 5 is also 5 in this mode 5. So we're going to divide it by 5. That is 5 divided by 5 is equals to 1 remainder 0. So answer is 0 mode 5. This is very easy. Now I'm going to give you questions that make division a very tactical part of modular arithmetic. If we have a question like 48 divided by 5 in mode 8. First of all, I know some people will start solving it like this, but this is not how you solve it. This is where we introduce a variable known as x. Let me show you how. First of all, we'll put it in this format. 48 divided by 5. How do we introduce x? X over 1 is equals to 48 divided by 5. We cross multiply. 5 times x is equals to 5x, and 48 times 1 is equals to 48. In mode 8. Now we all know 48 is not a multiple of 5. So we are going to be adding 8 to this 48 so we get to a number that can be divided by 5. So this is 5x. 48 plus 8 is equals to 52. This is not a multiple of 5. This cannot be divided by 5. So we're going to solve another question involving division. A very tactical one. Let me show you how division is easy but tactical. Number 2. 50 divided by 6 in mode 5. I know some people will start dividing it like this, but this is wrong. This is why it is tactical. So this is where we introduce a variable known as x. First of all, put it in this format. 50, this division, across like this, divided by 6. How do we introduce x? We say x over 1 is equals to 50 divided by 6. We cross multiply. 6 times x is equals to 6x. 50 times 1 is equals to 50 in mode 5. So 50 is not a multiple of 6, so 6 cannot divide 50. So we keep on adding 5, so we get to a multiple that can be divided by 6. 5 plus 50 is equals to 55. 6x is equals to 55. 55 cannot still be divided by 6, so we add another 5 to this 55, which is equals to 60. Now 60 is a multiple of 6, so we divide both sides by 6 to make x stand alone. This 6 cancel this one. This goes like this. So therefore x is equals to 10. We cannot leave our answer in 10 because 10 is bigger than 5. This is why it's very tactical. So therefore, we will now say these are 10. We divide it by 5, which is now 2 remainder 0. And modular arithmetic deals with the remainder, so your answer is 0 in mode 5. This is why division is a very tactical part in modular arithmetic, but I made it very easy for you. Thank you very much.